Welcome to Mysteries of Earth, where we uncover the forgotten stories of our universe and explore the questions that challenge everything we think we know. If you love exploring ancient mysteries, lost civilizations, and the secrets of space and time, make sure to like this video, subscribe, and turn on notifications so you never miss an episode. Today we turn our gaze toward our nearest neighbor, a world that once shimmered with oceans, clouds, and perhaps life. Before Earth ever bloomed, Mars may have already lived its story, a planet now silent, its rivers dry, its surface scarred by time. Could civilizations have risen there, thinking, building, dreaming, long before life awakened on Earth? Could their legacy still linger in the dust, or even within us? Join us as we journey beyond Earth's timeline into the forgotten history of a neighboring world to ask the question that could rewrite our origin. What if civilizations existed on Mars before Earth? Before Earth ever bloomed with forests and oceans, another world may have already known life. Mars, a planet we now see as barren, frozen and silent, was once alive with motion. Its rivers carved valleys across ancient plains. Its skies, tinted by a thinner sun, may once have shimmered blue, and beneath that faded sky, perhaps, something more than water and wind stirred. Billions of years ago, Mars was not the dry desert we know today. It was a world of warmth and possibility. NASA's orbiters have traced the ghostly paths of rivers that once ran for thousands of kilometers, branching like veins across the surface. Massive deltas mark where ancient rivers spilled into crater lakes, and mineral deposits tell us those waters lingered for millions of years. For a time, Mars may have looked more like Earth than any other world we know. In those early days, the two planets were siblings, both cradled in Tethys, his sun's gentle warmth, both rich with carbon dioxide and nitrogen, both capable of supporting oceans and clouds. But fate diverged. Earth's magnetic field held fast, protecting its atmosphere from the solar wind. Mars, smaller and less shielded, began to lose its breath. Bit by bit, its air was stripped away, its seas evaporated into the thin sky, and its warmth bled into space. What remained was the cold, rust-red desert we see today, a planet frozen in memory. And yet, even in its silence, Mars speaks. The rocks whisper of water, of chemistry, of time. The meteorites that journeyed from Mars to Earth carry within them structures that some scientists believe could be microfossils, hints, perhaps, of ancient biology. The Curiosity and Perseverance rovers have found complex organic molecules, the carbon-based foundations of life itself, locked within Martian stone. But the question remains, did these ingredients ever awaken? Did life on Mars take that crucial next step? From chemistry to biology, from potential to presence? If Mars was once alive, it would not have been alone for long. During the same epoch, Earth was only just forming oceans, its surface still cooling from the chaos of creation. Mars, with its stable climate and liquid water, may have been the more hospitable world, the first cradle of life in our solar system. And if life arose there first, the implications ripple outward in every direction. We often imagine Mars as a place of ancient ruins. Cities buried in dust, monuments eroded by time. While science has found no proof of such civilizations, the idea persists because it echoes something deeper within us. The sense that life does not begin and end in isolation. The story of existence may not belong to one planet alone. There is another possibility, one rooted in science rather than myth. It's called Panspermia, the idea that life, or the seeds of it, can travel between planets. When massive asteroids struck Mars billions of years ago, they blasted chunks of its crust into space. Some of those rocks eventually fell to Earth, carrying within them the chemical fingerprints of a world that once had water, warmth, and time. If even a few microscopic organisms had survived the journey, they could have seeded life here. In that case, Earth would not be the birthplace of life, but its continuation. Under that scenario, we are not merely explorers of Mars. We are its descendants. Our DNA would carry the memory of another world, one that thrived and died long before Earth was ready to host its first living cell. The story of life, then, would not begin under a blue sky, but beneath a red one. And yet, the evidence remains elusive. Mars today is silent. Its surface blasted by radiation, its air too thin to breathe. The rivers that once shimmered in sunlight are now only shadows in rock. But if civilizations once rose there, or even if life once stirred in its ancient seas, the traces may still be waiting, hidden beneath the dust, preserved in ice, or entombed in the crust where time cannot reach. The search for those traces has become one of the great scientific quests of our age. NASA's rovers wander through ancient lake beds, drilling into rock, collecting samples to one day return to Earth. Each fragment they gather could hold a clue, a chemical signature, a fossilized microbe, a whisper from a time when Mars was alive. Even the silence has meaning. It teaches us how fragile habitability can be, how close Earth itself may have come to the same fate. In this forgotten world beneath the red sky, we see a mirror of our own. Mars reminds us that every planet has a story. One of birth, change and loss. Once it may have been a place of clouds and rainfall, of oceans and winds that shaped a living world. Now it stands as a monument to impermanence, a world that almost made it. Perhaps civilizations never rose on Mars. Perhaps life there never evolved beyond simple cells. But even so, its story matters. Because in understanding Mars, we are really searching for ourselves, for the origin of the spark that began the long chain of existence leading to us. And maybe, just maybe, that spark did not start here. For now, the evidence lies buried, waiting for the right eyes, or the right hands, to uncover it. Mars keeps its secrets well, but not forever. Each rover wheel that rolls across its dust, each sample returned to Earth, brings us closer to knowing whether we are truly children of Earth or of something older. Because if Mars once lived, even for a brief shining moment, then life is not rare and civilization may not be unique. The universe may be filled with forgotten worlds, each carrying its own story of creation, destruction, and survival. And so as we leave behind this first glimpse of the red planet's hidden past, one question lingers in the dust. If Mars truly was once alive, what else might still be waiting to be found beneath its ancient sky? In the summer of 1976, a camera orbiting hundreds of kilometers above Mars captured an image that would ignite one of the most enduring mysteries of space exploration. It was a simple grayscale photograph, sunlight sweeping across the region known as Cydonia, shadows falling across ancient rock. But in one of those shadows, something remarkable appeared. A face, broad forehead, deep eye sockets, a ridge of a nose, the faint suggestion of a mouth. It stared upward from the Martian desert as though carved by ancient hands and left to watch the sky for eternity. The photograph, taken by NASA's Viking 1 orbiter, became an instant sensation. Newspapers printed it on their front pages. Scientists, artists, and dreamers debated it on television. To many, it was evidence, or at least the possibility, that Mars was once home to intelligence, a civilization capable of art, architecture, and memory, a civilization that had left behind a monument in its own likeness. To others, it was nothing more than coincidence, a trick of light and shadow on a lumpy mesa, a pattern that meant nothing at all. But the face on Mars, as it came to be known, would transcend both camps. It would become a symbol of something deeper, our longing to find ourselves in the cosmos. At the heart of this mystery lies a simple truth about perception. Human beings are storytellers by nature. We search for patterns, in clouds, in constellations, in the chaos of random noise. Our minds evolved to recognize faces, to connect shapes into meaning. It's a survival instinct, one that once helped us distinguish friend from foe, human from predator. But that same instinct can also deceive us. Psychologists call it pareidolia, the tendency to see familiar forms where none exist. A face in the moon, animals in the clouds, a man on the surface of toast. On Mars, it became a civilization in the sand. When Viking 1 sent back its now famous photograph, the resolution was limited. Each pixel covered nearly 50 meters of terrain. The sun was low, casting long, dramatic shadows that sculpted the landscape into human-like contours. To a mind primed for recognition, the illusion was irresistible. For decades, that image lingered in our collective imagination. It inspired books, documentaries, and even conspiracy theories suggesting that NASA was hiding the truth, that Mars had once hosted an intelligent species. Some believed the face was part of a complex of ruins, pyramids, and structures stretching across the Cydonia region. Theories spread like wildfire through the 1980s and 1990s, fueled by grainy photographs and the human desire to believe. But science, as always, is patient. In 1998, more than 2 decades after the Viking missions, NASA's Mars Global Surveyor revisited Cydonia with cameras far more advanced. It captured the same region at 10 times the resolution, and under different lighting. The new image told a different story. The face was no monument, no relic of a lost civilization, but a natural mesa shaped by erosion, time, and shadow. Under the high sun, its human features disappeared, replaced by slopes, ridges, and rock. The mystery had been solved, at least scientifically, yet the fascination persisted, because perhaps deep down we didn't want the mystery to end. The face on Mars had become more than a geological formation. It was a mirror, not of Mars, but of ourselves. It revealed our longing for connection, our hunger to find meaning in the cosmos, and our fear that we might be alone. Every age of exploration carries its illusions. Sailors once believed they saw cities in the clouds or gods in the stars. Now, in the space age, we look for ourselves on alien worlds. The face on Mars reminded us that the line between discovery and imagination is often thin, that wonder and science are not opposites but partners. When we look at Mars, we do not see it as it is. We see it as we hope it might be. Alive, familiar, a place where stories could begin, and in that way the illusion served its purpose. It drew attention, curiosity, funding, and passion to the exploration of Mars. What began as a shadow in the sand became a spark that reignited our quest to know the planet more deeply. The irony is that while the face turned out to be an illusion, the deeper truth it symbolized, that Mars might once have been alive, remains very real. Since Viking, we have sent fleets of orbiters, landers, and rovers to Mars. Each has uncovered new pieces of a far greater mystery. Satellite imagery shows dried river valleys and delta formations, unmistakable evidence that water once flowed there. Mineral analysis reveals clays and carbonates that form only in the presence of liquid water. Ancient lake beds like Jezero Crater, now explored by NASA's Perseverance rover, preserve layers of sediment that could hold the chemical fingerprints of life. The search for biology on Mars continues, not in the form of stone faces, but in microscopic patterns of carbon, hydrogen, and sulfur. We now seek fossils not of cities, but of cells, and yet even as science moves forward, the legend of the face on Mars endures, as if some part of us still wishes it were true. Because behind the rational search for microbes lies something deeply human, the hope that we are not the first to wonder, not the first to dream beneath the stars. If life once flourished on Mars, even briefly, it changes everything. It means that life is not a miracle confined to one world, but a natural consequence of the universe itself. It means the spark of biology may ignite wherever conditions allow. In the warmth of a Martian sea, the ice of Europa, or the clouds of Venus. And if intelligence once rose there, however fleetingly, then consciousness may not be unique either. It may be a recurring phenomenon, like stars, like planets, like time. In the end, the face on Mars is less about what it showed and more about what it revealed in us. It taught us humility, the need to separate hope from evidence, wonder from illusion, but it also reminded us that wonder has its place. Without it, we would never have sent cameras to Mars in the first place. Science begins with curiosity, but it survives on skepticism. The story of the face on Mars carries both. It is the dance between imagination and understanding, between the myths we inherit and the truths we discover. Mars, stripped of illusion, remains no less mysterious. Its rocks still hold secrets of a time when rivers ran and climates changed. Its valleys whisper of habitability. Its dust may still conceal the chemical shadows of life. The face was an illusion, but the question behind it, was Mars ever alive, remains as haunting as ever. As we move forward in our search, we must remember that the truth of Mars may not come to us as a sculpture or a monument, but as a molecule, a fossil, or a pattern written in stone. The face we seek may not be in the sand, but in the mirror. Because in our longing to find life elsewhere, we are also searching for ourselves, for the part of us that refuses to accept that we are alone in an infinite universe. And so as we turn away from the illusions of shadow and light, we begin to see the real mystery emerging beneath them, the true evidence of what Mars once was and what it might still be. From orbit, Mars is a landscape of riddles. Vast canyons slice through its surface like the veins of an ancient world. Dunes ripple across frozen plains. Mountains rise where volcanoes once roared. But among these natural forms there are shapes that seem to whisper something more, patterns that look deliberate, geometric, almost architectural. Triangular hills arranged in near symmetry, rectangular plateaus aligned to the cardinal points, ridges that appear to form grids like the faint blueprint of a forgotten city. To the human eye, it's irresistible. These patterns suggest the possibility that Mars once bore structures, monuments, or ruins left behind by something or someone. But to the scientific mind, they are a test. Because between what we see and what is real lies a canyon as deep as Valle Marineris. The debate began decades ago when early satellite images revealed the Martian surface in grainy shades of grey. Some features caught attention, formations in regions like Cydonia, Arabia Terra, and Elysium Planitia that looked, at first glance, too ordered to be natural. Triangular pyramids, clusters of hills aligned like planned architecture. For some, these were not coincidences. They were remnants, ruins eroded by time and wind, the last traces of a civilization older than Earth's. Authors and researchers outside mainstream science proposed bold theories that Mars once hosted intelligent beings, that cataclysms erased their world, that what we now see as desert was once city, temple, and home. To others, these claims were examples of pareidolia, our brain's instinct to impose meaning on randomness, to turn geology into geometry. Science asks for evidence. It demands more than pattern. It seeks purpose, context, and mechanism. If these shapes were truly artificial, we would expect to find supporting clues. The debris of tools, inscriptions, alloys, or artifacts not explained by wind or water, but none have been found. Still, the mystery endures because the forms themselves refuse to vanish. Modern imaging technology has transformed our view of Mars. High-resolution cameras aboard orbiters like Mars Reconnaissance Orbiter and Mars Odyssey have photographed these regions in stunning detail, down to resolutions of less than a meter per pixel. What looked like pyramids from afar are revealed up close as mesas, steep-sided hills sculpted by erosion, their symmetry born of wind, sediment, and ancient floods. What seem to be aligned complexes turn out to be natural fracturing patterns in rock, shaped by tectonic stress and the freeze-thaw cycles of Martian weather. Nature, it seems, is the greatest architect of illusion. Yet, even as each explanation is offered, the emotional question lingers. What if this time it isn't just erosion, because our search for order is not rooted in delusion? It is rooted in experience. On Earth, ancient structures like the pyramids of Egypt, the temples of Mesoamerica, and the monuments of Mesopotamia share geometric features not unlike those we glimpse on Mars. We recognize them because we built them, and so when we see similar forms elsewhere, we instinctively wonder whether intelligence once walked there too. There's another layer to this debate, one that goes beyond geology. It's about time. If intelligent life did arise on Mars, it would not necessarily have been recent. Geological evidence suggests that billions of years ago, Mars was warmer, wetter, and more habitable than it is today. Rivers flowed through its valleys, lakes filled its craters. Life, microbial or even complex, could have evolved under those conditions. And if it did, civilizations might have emerged, thrived and vanished long before Earth was ready for its first multicellular creature. But the longer the time scale, the more fragile the evidence becomes. Erosion, volcanic resurfacing and meteor impacts would erase nearly every trace of technology or architecture over millions of years. Even on Earth, human monuments would crumble to dust within a few 100,000 years if left unmaintained. On Mars, with its relentless dust storms and freeze-thaw erosion, even great cities could vanish without a trace, leaving only ambiguous forms in the rock. So perhaps the question is not whether the shapes we see are ruins, but whether any ruins could survive long enough for us to recognize them at all. Science, though skeptical, does not dismiss the spirit of the question. It evolves with it. The study of geointelligence, analyzing planetary surfaces for potential artificiality, has become more rigorous. Algorithms can now detect unnatural symmetry, geometry, and composition, comparing them statistically to known geological formations. So far, the verdict remains. Mars shows no confirmed evidence of artificial structures, but the tools grow sharper every year. And beneath that, something deeper stirs. A philosophical question about how we recognize intelligence. Would we even know it if we saw it? If alien design differed completely from our notions of architecture or geometry, we might walk past its traces without understanding. We look for right angles, perfect circles, repeating patterns, because those are our signatures. But another civilization might build with principles beyond our perception, materials beyond our spectrum, motives beyond our logic. So perhaps the ruins we seek aren't made of stone at all. Perhaps they exist in chemical traces, in magnetic anomalies, in microscopic architecture invisible to the eye. Perhaps the civilization we imagine was biological, not mechanical. Its legacy encoded in DNA-like molecules scattered through Martian soil. And yet, the debate remains human. Between belief and skepticism lies an ancient tension, the same one that drives all discovery. The believer sees meaning everywhere. The skeptic demands proof. Both are essential, for belief without proof is fantasy, but proof without wonder is empty. The shapes on Mars, the so-called pyramids, the ridges, the faces, remind us of this delicate balance. They challenge us to question both our imagination and our arrogance. They show us how easily the universe can reflect our hopes back to us, disguised as evidence. Because in truth, every shadow we interpret, every hill we label as a temple, reveals less about Mars and more about ourselves. Our longing to find civilization elsewhere is, at its heart, a longing to know that consciousness is not unique, that we are part of something greater, woven into a larger story of life that extends beyond one fragile blue world. In the end, the rocks of Mars stand silent. They offer no inscriptions, no ruins, no monuments, only shapes. Shapes that tempt us, challenge us, and remind us of how much we still do not know. But that silence is not emptiness, it is an invitation. An invitation to keep searching, not just for civilizations of the past, but for the truth of how life begins, evolves, and perhaps ends across worlds. Because whether those hills are ruins or rocks, they point us toward the same question. What happened here, on this frozen desert, that made a once-living planet fall silent? And could the same story one day unfold on Earth? On Mars, time does not pass. It devours. Every second, every century, every eon, it grinds the planet down, reshaping mountains into dust, erasing whatever stories might once have been written upon its face. If Mars ever held civilizations, oceans, forests, or life, they are gone now, not by war, nor fire, nor flood, but by the slow, patient hunger of time itself. Because on Mars, time is not merely a measure of change. It is the great eraser. From the moment its magnetic field faded, Mars became naked before the sun. Radiation, once deflected, began to strike its surface with relentless force. Solar winds tore at its atmosphere, molecule by molecule, until the air grew too thin to hold warmth, too sparse to carry rain. What was once a blue world turned red. The oceans vanished, boiled away, or frozen beneath the crust. Rivers that once carried life now mark their dry beds like scars across a forgotten skin. The skies, once thick with clouds, became brittle with dust. And that dust, fine as smoke, sharp as glass, has swept across the planet for billions of years, reshaping everything it touches. The Martian wind is not like the wind of Earth. It is slow, cold, and yet endless. It carries particles that carve the rock, layer by layer, until even mountains lose their names. Over time, every trace of pattern, every monument of stone, every fossilized form is softened, erased, absorbed back into the landscape. Here, nothing endures. On Earth, we measure time through the persistence of memory, in fossils, ruins, and written words. But on Mars, memory has no refuge. The thin atmosphere offers no shield against radiation. Cosmic rays, ultraviolet light, and solar particles bombard the surface, breaking molecular bonds, sterilizing soil, and erasing chemical signatures of what once might have lived. Even DNA, if it ever existed here, would not survive long. In a few million years, the radiation would shred it beyond recognition. To find traces of ancient life, we must look deeper. Buried beneath layers of rock and ice, where time's reach weakens, where the great eraser's hand cannot fully grasp. That is where we search now, not for cities or statues, but for whispers, carbon isotopes, fossilized bacteria, chemical ghosts preserved in clay. It's humbling to think that even if a civilization had once stood upon the Martian plains, cities carved into stone, towers built toward a faded sun, it would have been erased completely. Erosion is the ultimate equalizer. Even on Earth, where air is thick and life is abundant, our grandest creations will not last. The pyramids, the skyscrapers, the satellites, all of them are temporary. Given enough time, the planet will reclaim them all. Now imagine that process magnified across billions of years without life to rebuild or repair. That is Mars. A world left to the mercy of physics. Here, even stone is fragile. Dust storms can last for months, engulfing the entire planet in a veil of rust. The surface is constantly bombarded by micrometeorites, each impact shattering and scattering fragments of the past. Over ages, those fragments are ground down into sand, blown across the plains, buried beneath new layers of dust, compacted and buried again, until whatever once was is not destroyed, but transformed. It is not that Mars forgot, it is that Mars was rewritten. The oldest rocks on Mars may hold the planet's deepest secrets, but they are also the hardest to read. Crater impacts mix the layers, making ancient sediments indistinguishable from newer ones. Volcanic flows from Olympus Mons and Tharsis buried vast regions under molten basalt, sealing away whatever lay beneath. And the planet's global dust cycle ensures that even freshly exposed surfaces are soon hidden again, as though Mars itself is determined to keep its history veiled. Time on Earth is cyclical. Life renews, erosion gives way to growth, the past gives birth to the present. But time on Mars is linear, irreversible, absolute. Every change is a subtraction. Every century is a loss. Yet even in this oblivion, there are traces of endurance. Ancient riverbeds still mark the paths of vanished waters. Sedimentary layers tell of climates that came and went. Polar ice caps preserve a record of Martian seasons, frozen in delicate rings of dust and frost, and buried deep within certain rocks, radiation-damaged crystals still whisper of the planet's magnetic field, the one that once shielded it before vanishing forever. In these remnants, Mars still remembers. Not in the way we remember, through stories or symbols, but through matter itself. Each mineral, each fracture, each isotope is a word in the long silent language of time. To read that language is to realize how small our concept of history truly is. We measure our civilizations in centuries, our species in millennia, our planet in billions of years, but the cosmos measures in something deeper, in transformations so slow, so complete, that memory becomes indistinguishable from creation itself. For scientists, Mars is not just a planet, it is a mirror. It shows us what happens when time is allowed to rule unchecked, when no biology remains to resist entropy, when no hands rebuild what the wind has worn away. It is a glimpse of Earth's own distant future, long after our cities fall silent and our oceans dry. Because one day, even here, time will win. Every monument, every name, every memory will vanish, as if they had never been. But that truth is not despair. It is perspective. It reminds us that while time erases, it also preserves. The dust that buries may also protect. The ice that conceals may also guard. And somewhere beneath the Martian surface, locked away from radiation and storm, something may still remain. A fossil, a microbe, a molecular imprint of a story too ancient for us to yet comprehend. Mars teaches us that permanence is an illusion, but so is finality. For even in a world consumed by time, echoes endure. Each grain of dust is a relic. Each crater is a memory. Each eroded valley is the shadow of something that once was, and might yet be again. Perhaps, in the distant future, when Mars is reborn under another sun, time will once more write upon its face. New winds will blow, new waters will flow, and life, in whatever form it takes, will begin its story again. And just as we search for traces of what came before, they too may one day search for us. There are worlds that die quietly, fading beneath their own silence, swallowed by time. And then there are worlds that fall in fire. Mars, it seems, may have known both kinds of death. Its rivers dried, its atmosphere thinned, its warmth bled away into the dark. But some believe the end came not gradually, but violently. For decades, a quiet debate has lingered at the edge of science. Was Mars' desolation the result of nature's slow decay, or the echo of a single, unimaginable catastrophe? It began with a mystery in the data, strange readings from orbit, traces of isotopes in the thin Martian air that didn't seem to belong. When scientists analyzed Mars's atmosphere, they found unusual ratios of xenon isotopes, particularly xenon-129, far higher than those typically found in planets or asteroids. To most, the explanation was simple. Ancient cosmic radiation, natural decay from radioactive materials, the aftermath of impacts that once shook the planet's crust. But to a few, it hinted at something else. In the early 2010s, a physicist named Dr. John Brandenburg proposed a controversial idea that these isotopic patterns resembled those found on Earth after thermonuclear detonations. He suggested that long ago Mars may have witnessed a nuclear-scale explosion, perhaps from natural causes, or from something far stranger. The theory captured imaginations, not because it was proven, but because it spoke to something deeper. Our longing to find stories written in the dust, to believe that catastrophe might also mean history. Of course, science demands caution. There are many ways to produce xenon-129 without invoking weapons or civilizations. Supernova remnants, asteroid impacts, and cosmic ray interactions can all scatter radioactive isotopes across planetary surfaces. And Mars, battered by billions of years of bombardment, has certainly endured its share of cosmic violence, the planet bears the scars. Vast basins like Hellas and Argyre stretch for thousands of kilometers, craters so deep they pierce the crust itself. The northern lowlands are likely the remains of a colossal impact, a blow so immense it may have tilted the planet's axis and reshaped its entire climate. Each of these impacts released more energy than 1 million nuclear bombs combined. If the surface of Mars is haunted by radiation, it may simply be the lingering signature of such cosmic events. Yet, the question remains. Because the isotopes are not evenly spread, they seem concentrated in specific regions, the same regions where strange landforms, sometimes called ruins or anomalies, have been noted by orbital cameras. Coincidence? Almost certainly. But coincidence is the seed of curiosity. In science, there's a tension between what we can measure and what we imagine. The nuclear Mars hypothesis may be improbable, but it forces us to confront something real. Mars did suffer catastrophe. Whether that catastrophe came from the sky or from within, its effects reshaped the planet forever. Around 4 billion years ago, Mars was alive with motion. Volcanoes, like Olympus Mons, rose taller than any mountain on Earth, fueled by a molten heart. Magnetic fields circled the planet, protecting it from solar wind. Rivers carved valleys. Clouds drifted above shallow seas. Then, something changed. The magnetic field faltered. Without it, the atmosphere was stripped away. The planet cooled. The great volcanoes went silent, and the water, once free to flow, began to vanish. Whether this was a slow decline or a single cosmic blow remains uncertain. But in either case, it was the moment Mars began to die. We know that Mars has experienced colossal impacts, enough to crack crust, vaporize oceans, and fill the sky with fire. In one scenario, a massive asteroid, perhaps 1,000 kilometers wide, struck near the northern hemisphere. The shockwaves spread across the planet, melting rock, releasing gases, and filling the air with radiation. If life existed then, it would have been annihilated in an instant. If civilizations had arisen, as some dreamers suggest, they would have been erased completely, their memory scattered into the dust. Perhaps this is why Mars is so haunting. It is not just the possibility that life once existed there, but that it might have ended there. Even in the absence of proof, Mars tells the story of fragility. Its once warm climate depended on balance, heat, atmosphere, magnetism, all of which unraveled in cosmic time. A small planet, cooling too quickly, lost its shield and became a victim of the very star that once gave it life. From orbit, we can still see the traces of this undoing: dried river deltas, collapsed lava tubes, and minerals that could only have formed in water. They whisper of an age when Mars was not red, but blue and gold, a living world under a dimmer sun. Then came silence. The winds grew thin. The seas froze. The light of the sun grew cruel. And the planet that once might have known life became the grave of its own potential. To imagine Mars as the site of catastrophe is not fantasy. It is a way of understanding the violence written into the universe itself. Planets are born in chaos, they live in balance, and they die in entropy. Sometimes the death comes slowly. Sometimes it comes in an instant. An asteroid's flash, a solar storm, a chain of volcanic convulsions. And sometimes, perhaps, it comes by its own hand, through intelligence that outgrew its wisdom. That last possibility that a civilization could end its world is not really about Mars at all. It's about us. Because if Mars did once harbour intelligence, and if that intelligence vanished beneath the weight of its own creations, then its story is a warning written across the stars. A message from a planet that once stood where we stand now, on the edge between flourishing and extinction. Most scientists dismiss the nuclear hypothesis as speculation, and rightly so. There is no evidence of technology, no ruins, no signs of art or architecture. But that doesn't make the question meaningless, because behind it lies something true. That worlds can change abruptly, catastrophically, and forever. That life, and perhaps even civilization, can vanish so completely that only isotopes remain to tell the tale. Mars is a record of cosmic violence, whether by nature or by choice. It reminds us that the line between a living planet and a dead one is thinner than we think. One magnetic field, one asteroid, one chain reaction away. And in that realization, Mars becomes more than a world. It becomes a mirror showing us both the fragility of creation and the shadow of what we might yet become. When a world begins to die, life has only two choices: adapt or vanish. And on Mars, where the seas froze and the air escaped, perhaps something chose to adapt. Imagine a world in its final breaths. Rivers turning to dust, winds whispering over empty plains, the sun a faint, distant ember. On the surface, death ruled. But beneath, in the hidden chambers of rock and ice, life may have refused to surrender. Could there have been survivors? Not in cities or civilizations as we imagine, but in the quiet persistence of biology, a struggle written into every molecule of life. As the Martian climate collapsed billions of years ago, water, the foundation of all we know, retreated underground. What was once ocean became permafrost. What was once river became mineral vein. Yet, where there is water, even in trace amounts, there may still be the possibility of life. Beneath the planet's desolate crust lies a world untouched by the raging storms above. In these dark, frozen aquifers, shielded from radiation and temperature extremes, microbes could have found refuge. They would have adapted to scarcity, feeding on chemical energy rather than sunlight, drawing sustenance from minerals, perhaps thriving in brines so salty they never froze. On Earth, such life already exists. In the Antarctic dry valleys, bacteria sleep within crystals of ice, awakening only when moisture returns. Deep in our own crust, kilometers below ground, entire ecosystems flourish in eternal darkness, surviving on hydrogen, sulfur, and the faint heat of the planet's core. If life can persist here, it could persist there. And so the question lingers: did something crawl beneath Mars as the surface froze, clutching to existence as the world above turned to stone? Modern science has begun to look for answers. The European Space Agency's Mars Express and NASA's Mars Reconnaissance Orbiter have detected strange reflections beneath the South Polar ice cap, radar signals bouncing off something smooth, dense, and possibly liquid. Some scientists interpret this as a buried lake, rich in salts, kept from freezing by pressure and chemistry rather than warmth. Others argue it might simply be layers of clay or mineral deposits. But even so, the discovery reopened a profound question. If water still flows beneath the Martian surface, even in small amounts, could something still live there today? Robotic explorers like Curiosity, Perseverance, and Jurong have found organic molecules in ancient rocks, carbon-based compounds that, on Earth, are the signatures of life. They've also found seasonal bursts of methane, a gas that, while sometimes geological, is also a byproduct of living organisms. Each trace, each molecule, is a whisper, faint, uncertain, but persistent. If anything survives on Mars now, it would not resemble the life we know. It would be ancient, microscopic, adapted to radiation and cold, evolving not for beauty or complexity, but for endurance. Perhaps in the distant past, when Mars still had lakes and clouds, this life flourished in warmth and light. But as the atmosphere thinned and the temperature plummeted, it descended, following the last traces of moisture into the planet's veins. Over millennia, it would have changed. Metabolism slowed to a crawl. Cells hardened against desiccation. Life became endurance incarnate, a form of existence that measures time not in years, but in eons. In that sense, the last Martians may not be gone at all. They may simply be waiting, in frozen sleep, beneath kilometers of rock, in the silence of a dead world. But what if survival went beyond biology? What if, long before the final collapse, Mars once nurtured not just microbes but intelligence? If such beings existed, civilizations capable of thought, culture, or even technology, how might they have faced the coming extinction? Would they have built shelters underground, seeking warmth and air as the surface froze? Would they have fought to terraform their own dying world? Or look to the sky dreaming of escape to another? These questions stretch the boundary between science and myth. We have no ruins, no artifacts, no monuments to confirm them. Yet, the human mind is drawn to the possibility, because extinction is a mirror we cannot look away from. If intelligence ever did arise on Mars, it would have confronted a truth that all civilizations eventually face, that nature is vast, indifferent, and ultimately patient. Even the brightest minds cannot stop the slow dimming of a world. They can only choose how to face it, with denial or with adaptation. In the end, survival on Mars may not have been about species or civilizations, but about persistence itself, life refusing to yield to cosmic inevitability. And in this, Mars becomes a lesson in humility, because while we dream of colonizing other planets, we forget that nature already wrote the script for survival long ago, not with machines, but with microbes. Creatures that outlast cataclysm not through strength, but through stillness, through endurance. Perhaps the last Martians were not architects, but organisms, drifting beneath the crust, unseen and undying, waiting for the world above to heal. And perhaps in the cold silence of that planet, they still exist, patient, ancient, watching the sky. Every mission we send, every rover, every probe, is not just a search for life, but for memory. We are looking for the survivors of time itself, for traces that say, "We were here, we endured." And if we ever find them, even a single dormant cell trapped in ice, it will change everything. Because that discovery would mean that life is not unique to Earth. It means the universe itself is alive with possibility, and that extinct Mission is not always the end. The story of Mars, then, is not just a tragedy, it is also a testament to endurance, to the possibility that even in a dying world, something can hold on. That life, once begun, resists oblivion with every atom of its being. Perhaps that is the true legacy of Mars, not the mystery of its fall, but the resilience of what might still remain. Because if life did survive, if somewhere beneath those red deserts the last Martians still slumber, then they are not just remnants of another world. They are proof that life itself is the universe's most powerful instinct, the will to continue even when everything else has ended. When the red planet began to die, perhaps its people looked to the stars, not in wonder, but in desperation. They would have watched their oceans retreat, their skies thin, their warmth fade away. Every passing century stripping the world of breath and colour. And then one thought might have united them all: escape. If Mars once flourished with life, and if intelligence ever emerged there, then its final chapter may not have ended in extinction. It may have ended in migration to a world young, blue, and full of promise. To Earth. At first glance, this sounds like myth, a story born of hope and imagination. But science, in its quiet way, has left the door slightly open, because Mars and Earth are not strangers. They are cosmic siblings, formed from the same swirling cloud of dust and gas, orbiting side by side for over 4 billion years. And they have been exchanging material almost since the beginning. When giant asteroids slammed into Mars, chunks of its surface were hurled into space, fragments of a dying world drifting through the void until, eventually, some fell upon Earth. These meteorites, found in deserts and ice fields across our planet, are literal pieces of Mars, ancient messengers that crossed the gulf of space long before any spacecraft did. Inside them, scientists have found structures and chemical signatures that hint at something extraordinary. In one, called AL 8401, discovered in Antarctica, microscopic formations appeared eerily similar to fossilized bacteria. For a moment, the world stood still. Had we just found proof of Martian life, not in the stars but in our own hands? Skeptics argued that the shapes could be mineral artifacts, formed by geology rather than biology. And perhaps they are. But the discovery raised a haunting possibility. If life ever existed on Mars, could it have traveled here, not through spaceships or technology, but through nature itself? This concept, known as Panspermia, suggests that life might spread between worlds like seeds on a cosmic wind. When meteorites crash into a planet, they can carry microbes, microscopic travelers that, if shielded within rock, might survive the violent journey through space. Once they land on a new world with water and warmth, they could awaken, evolve, and begin again. If this happened from Mars to Earth, then the story of life on our planet may not have begun here at all. It may have begun there, in the soils of another world, under a red sky. And if Mars once hosted intelligent life, then perhaps the transfer was not accidental. Perhaps it was deliberate. Imagine a civilization standing on the brink of extinction, their atmosphere thinning, their crops failing, their seas freezing. They would have turned their minds towards survival, searching the heavens for a new home. And there, glowing faintly in the night sky, was Earth, vibrant, young, and full of potential. Could they have built vessels to carry their last generations across the void? Could the first humans have been Martian refugees, the distant descendants of another world? Mainstream science remains cautious, of course. There is no direct evidence of intelligent life on Mars, let alone one capable of interplanetary travel. Yet curiously, ancient human myths whisper stories that echo the same theme. Many ancient cultures, from Sumerian to Egyptian to Mayan, speak of gods or beings who came from the heavens, bringing knowledge, agriculture, and language. The idea that civilization was given to humanity, not invented by it, is a recurring thread through the world's oldest stories. Could these myths be distant memories, distorted by time, of something real, a visitation, a migration, a crossing between worlds now lost to history? It is impossible to say. But what we do know is that the human brain seems tuned to remember what science often forgets, that we are, at our core, children of the cosmos. Even if no conscious Martian migration ever occurred, the biological connection remains compelling. Geneticists have traced the building blocks of life on Earth, amino acids, sugars, and nucleobases, to sources that could have formed in interstellar clouds or arrived on meteorites. In other words, life's chemistry may not be local, it may be cosmic. And that makes the idea of a Martian origin less fantasy and more part of an unbroken chain. From stardust to planet, from planet to life, from life to consciousness. So perhaps the Martian exodus is not about starships or refugees at all. Perhaps it is about inheritance. An inheritance written not in stone or myth, but in the molecular code of every living thing on Earth. If Mars was the first spark and Earth the flame that followed, then we are all, in some profound way, Martian. But let us, for a moment, entertain the wilder idea. If intelligent life did once walk the valleys of Mars, what might they have been like? Would they have resembled us, fragile, curious, reaching for meaning? Or would their minds, shaped by a colder sun and thinner air, have been entirely alien? And if they came here, could traces of their knowledge have survived, buried not in the ground, but in our own DNA, our myths, or the strange leaps in human evolution that science still cannot fully explain? It sounds impossible. Yet history has a way of turning impossibilities into discoveries, just as once we believed the continents were fixed, or that the planets circled Earth, or that life could only exist under a blue sky. Science advances by asking the questions we are not supposed to ask, and Mars continues to be the question that refuses to fade. So, whether the Martian exodus was biological, mythological, or metaphorical, it reminds us of something profound, that survival in any form is never the end of a story, only the beginning of another. Perhaps the last Martians did not die. Perhaps they became us. And in that sense, every step we take, every question we ask is not just human curiosity, it is ancestral memory, echoing across planets. Because maybe the reason we look to Mars with such longing is not because it's alien, but because it feels like home. Perhaps life did not begin here at all. Perhaps it wandered, drifting through the cold between worlds, carried on stone and dust, waiting for a planet kind enough to awaken it. This is the story of Panspermia, the idea that life is not bound to one world, but spreads through the cosmos like seeds on a galactic wind. It challenges everything we think we know about beginnings, and it whispers of a truth both humbling and profound, that life may not have started on Earth, but merely arrived here. To understand this possibility, we must first see the solar system as it truly is, not a collection of isolated planets, but a network of worlds in constant exchange. Every impact, every eruption, every cosmic collision sends fragments of planets hurtling into space. Over billions of years, trillions of tons of rock have leapt between Mars, Earth, the Moon, and even the outer worlds. Each fragment is more than stone. It is a potential vessel, a capsule of history, perhaps carrying microscopic passengers hidden deep within. When a massive asteroid strikes a planet, the surface beneath it can be blasted into orbit with such force that rock escapes entirely. And if some of those pieces avoid destruction in the heat of re-entry, they can wander for millions of years before finally falling upon another world. This is not speculation, it has happened again and again. We have found Martian meteorites on Earth and Earth rocks on the Moon. The solar system, in this sense, is not divided, it is connected, alive with exchange. So the question is not whether life could travel between planets. The question is whether it has. Inside certain Martian meteorites, like the famous ALH 84001, scientists have found tiny shapes that resemble fossilized microbes and traces of organic molecules, the chemical signatures of life. At the time of discovery, it was one of the most astonishing findings in planetary science. If confirmed, it would mean that the spark of life on Earth may have been lit by a visitor from another world. But science is cautious. Many researchers argue that the formations could be purely geological, the result of heat, minerals, and chemistry mimicking biology. Yet even if those structures are not fossils, the idea remains. If Mars once had life, and if fragments of it reached Earth, then our entire planet might be the offspring of another. Experiments have shown that some microbes on Earth can survive conditions we once thought impossible. They can endure freezing, radiation, even the vacuum of space. In 2020, bacteria left outside the International Space Station for years were brought back, still alive. And deep beneath Antarctic ice, or inside the salt crystals of deserts, life sleeps through ages of drought and awakening. If such resilience exists here, why not elsewhere? Why not in a rock flung from Mars, drifting through the cold void, carrying dormant cells within its sheltering crust, protected from radiation, frozen in time, waiting for a new dawn on a distant shore? When it lands on a world like Earth, warm, wet, rich in sunlight, it thaws. It breathes. It begins again. In that single moment, life does not originate. It migrates, and that migration could be the oldest story in the universe. Panspermia is not a single theory, but a family of ideas, each expanding the horizon of possibility. Lithopanspermia suggests that life can hop between planets on natural rock ejected by impacts, exactly as might have happened between Mars and Earth. Radiopanspermia imagines microbes drifting freely through space, pushed by the pressure of starlight, tiny voyagers crossing unimaginable distances. And directed panspermia, perhaps the most provocative of all, proposes that intelligent civilizations may have intentionas, airly spread life, seeding the cosmos as gardeners of creation. If such an act were ever real, it would mean that life itself is an artifact, not a random accident, but a deliberate message written in DNA, a universal code sent not to dominate, but to connect. The beauty of panspermia is not in its certainty, but in its perspective. It dissolves the boundaries between worlds, reminding us that the story of life may be shared. that Mars, Earth, and even Venus once participated in a cosmic chain of inheritance. Perhaps life arose once on one world in a single miraculous moment, and from there spread outward. Or perhaps it began everywhere, simultaneously, as if the universe itself had been waiting for the right chemistry to become conscious. Either way, it tells us that life is not rare. It is persistent. It finds a way to endure, to travel, to transform. In that sense, panspermia is not just a scientific hypothesis, and it is a philosophy of connection. When we look at our own reflection, in the mirror, in the sea, or through the eyes of another, we are seeing a lineage that may stretch across worlds. Our blood, our breath, our thoughts, all may carry echoes of alien beginnings. Perhaps we are not merely Earth-born, but universe-born. And if life can move between planets, then it can move between stars. The seeds of life could scatter across the Milky Way, each finding new soil, new worlds where oceans form and skies take shape, repeating the same cosmic experiment again and again. In this view, the galaxy becomes not an empty void, but a living network, a web of worlds connected by biology, not just gravity. Every world that harbors life would not be isolated, but part of a vast, invisible family tree. Even now, scientists test these ideas with missions to Mars, to icy moons, and to asteroids that might preserve the chemistry of life's origin. The more we learn, the more the lines blur between what is living and we. It is potential between what began here and what began somewhere else. And perhaps that is the greatest revelation of all, that life does not need a single birthplace. Because wherever there is chemistry, there is the possibility of memory. And wherever there is memory, there is the possibility of life. Panspermia reframes everything we know about existence. It suggests that life is not the exception to the universe. It is its natural expression. That we are not accidents of earthly chance, but participants in a cosmic continuum billions of years old. Maybe that is why we feel such deep longing when we gaze at Mars or at the stars beyond. Because somewhere in the atoms of our being, we remember. We remember the journey, through time, through space, through silence. We remember the dust and the fire, the exile and the arrival. We remember being seeds drifting on the wind of creation. Perhaps the most unsettling realization in all of science is this: we may not be what we think we are. For centuries, humanity has looked up at Mars and wondered if life ever existed there. But what if the answer has been looking back through us all along? What if life on Earth, every plant, every animal, every cell, is not truly native to this world? What if we are the descendants of Mars itself, a continuation of its story, written in our DNA? It sounds like science fiction, but it's an idea with deep roots in planetary science, one born from evidence, not imagination. The panspermia hypothesis suggests that life, or its precursors, can travel between planets aboard rocks blasted into space. And Mars, with its ancient rivers and atmosphere, may have once been a perfect cradle for that first spark. Billions of years ago, while Earth was still cooling under volcanic skies, Mars was warm, wet, and alive with chemistry. Its surface hosted lakes, river deltas, and even a global ocean. In those waters, the first molecular whispers of biology may have begun. Complex carbon chains forming, replicating, and evolving under the red light of a younger sun. But Mars was fragile. Its magnetic field faded. Its atmosphere thinned. The oceans evaporated into dust. If life had begun there, it faced extinction. And then, something extraordinary may have happened. A massive impact, one of countless cosmic collisions, struck Mars with such force that debris was ejected into space. Within that debris were fragments of rock, sealed tight like cosmic lifeboats, carrying within them the most precious cargo imaginable, life itself. Some of those rocks travelled across the void and found their way to Earth. When they entered our atmosphere, some burned away, but some survived. They landed on a young Earth, a planet filled with oceans, energy and potential, and in those oceans, life awoke again. If this truly happened, then our story, the story of humanity, does not begin on Earth. It begins on a different planet under a red sky. We are not children of Earth, but refugees from Mars. Scientists have found tangible evidence that supports at least the possibility of such a journey. Over 160 Martian meteorites have been identified on Earth, fragments ejected by impacts long ago. We know they came from Mars because of the gases trapped inside them, identical in composition to the Martian atmosphere measured by NASA's Viking missions. Inside some of these stones lie the faintest traces of what could be ancient biology, shapes resembling microbes, molecules that carry the patterns of organic life. While no discovery has yet proven that life existed on Mars, each piece of evidence nudges the possibility closer to reality. Even without fossils, chemistry itself tells the story. Mars and Earth share not only materials but timing. The oldest rocks on Mars are older than any on Earth, suggesting it had a head start. If life could form there first, then it had billions of years to evolve before sending its descendants to a safer home. In that light, Panspermia is not fantasy, it is survival, life's refusal to end. But this theory carries profound implications. If it is true, then every living thing on this planet, from the smallest bacterium to the human mind, carries Martian heritage. Our bloodlines stretch across planets. Our cells remember a world that once was. In the deepest biological sense, we are Martians. Imagine what that means for identity, for history. The cradle of life would not be the blue Earth we see today, but a distant, dying world whose children found a new beginning. Mars would not be a stranger to us. It would be home. Every time we send a rover to its surface, every time we drill its rocks or scan its canyons, he may be visiting our own past, uncovering the fossils of our ancestors, the echoes of a life that once looked to the same stars we now explore. Yet as poetic as it sounds, science demands humility. The theory of Martian ancestry remains unproven. We have yet to find living organisms on Mars or genetic material identical to ours. But evidence is building, piece by piece. We know that microbes can survive the vacuum of space, the radiation of cosmic rays, and the freezing cold of interplanetary travel. We have watched them endure for years outside the International Space Station, waiting to reawaken once returned to warmth and water. We know that Mars was once habitable, perhaps even inhabited, and we know that meteorites routinely exchange material between planets. Put these truths together, and the idea no longer seems impossible. In fact, it begins to feel almost inevitable. Perhaps then, Life has never been bound to a single planet. Perhaps it moves through the universe as it moves through us. Persistent, adaptable, unending. Mars may have given birth to the spark. Earth became its sanctuary. And humanity, conscious, curious, reaching toward the stars, maybe that spark's memory of home. When we gaze at Mars through telescopes or through the eyes of our rovers, we may be drawn to it not just by curiosity, but by instinct. Something ancient within us recognizes the red world. The dust feels familiar. The silence, strangely comforting. We are, after all, the continuation of its story, life that refused to vanish, that crossed the darkness to begin again. Our species may have simply taken up the thread that Mars began weaving billions of years ago. It's a thought both scientific and spiritual that our origins extend beyond the boundaries of Earth, that the universe itself is not indifferent but connected through life's persistence. We may think of ourselves as Earthlings, but perhaps we are citizens of a much larger history, one that began when dust and water first met beneath a red sky.
Rye atom in us once drifted among the stars. Every molecule of life once belonged to another world. And maybe long before our oceans existed, Mars already lived, dreamed, and died, so that we could exist at all.
Every rover that touches the Martian soil is more than a machine. It is an archaeologist of the future, a silent witness, digging through the ruins of time. Each image it sends, each sample it drills, is a brushstroke against the dust of an ancient mystery. For in that red dust may lie the story not only of another world, but of our own forgotten beginning. For centuries, Mars has been the mirror of human curiosity. We've seen it as a god, a twin, a possible home, and perhaps once a civilization. But now, as robotic explorers crawl across its plains, the dream has become a science. We no longer search for mythic canals or gleaming cities. We search for evidence, for fossils, artifacts, or even the faintest chemical memory of life. And yet, in a way, this search is deeper than archaeology, because what we are really unearthing is time itself. Beneath the rusted surface of Mars lies a layered history billions of years long. Its rocks preserve the scars of rivers, the fingerprints of wind, the echoes of volcanoes. Each layer tells a chapter of a planet that once breathed and flowed, a planet that might have known warmth, atmosphere, and life. Geologists studying data from orbiters like Mars Reconnaissance Orbiter and Mars Express have identified minerals that only form in water: clays, sulfates, and carbonates. These minerals are the pages of a lost geological library. If read carefully, they might tell us how Mars transformed from a world of oceans into a frozen desert. But some scientists look beyond geology. They see Mars as an archive of possibility, a place that may still hide the remains of something more complex than chemistry. The challenge is time. 4 billion years of erosion, radiation, and shifting sands have erased almost everything. If a civilization ever rose there, its ruins would not stand tall against the horizon. They would be buried, fragmented, scattered, disguised as stone. To find them would require patience beyond human lifespan and machines with the persistence of eternity. That is where our rovers come in. Curiosity, perseverance, and those that came before, Spirit, Opportunity, Sojourner, are the first archaeologists of a world that no longer remembers itself. Their tools are not shovels but spectrometers, drills, and cameras capable of reading the atomic language of stone. Each rover is part of a long, patient excavation, not of buildings, but of meaning. Curiosity found ancient riverbeds. Perseverance is searching the delta of Jezero Crater, once a lake that may have nurtured microbial life. It collects samples, not for us, but for the future, to be brought home one day by a generation yet to come. Those samples may contain what no telescope or robot has yet revealed, evidence that life once existed beyond Earth. If that happens, if we find fossilized microbes or traces of biological molecules, then humanity's most profound question may finally be answered. We will no longer wonder if we are alone. We will know that life is not an anomaly, but a pattern, a thread that weaves through the cosmos. But for some, the search does not stop at microbes. A smaller, more speculative group dares to ask another question. What if Mars once hosted not only life, but intelligence? It is a controversial idea. The face on Mars once ignited imaginations around the world, a formation in the Cydonia region that, in shadow, seemed to bear human features. When higher resolution images arrived decades later, it was revealed to be nothing more than a mountain of rock. Yet the fascination never truly died. Because behind the myth lies a haunting logic. If Mars once had oceans, atmosphere, and time, then it had the ingredients for evolution. And if evolution is universal, why not intelligence? Even NASA scientists acknowledge that Mars may have been habitable for hundreds of millions of years. That's enough time for life to rise, thrive, and vanish, leaving only geological whispers behind. If such beings existed, we would not find their cities or statues. We would find what the ages have left: irregular magnetic fields, isotopic anomalies, subtle patterns in the dust that speak of order long dissolved into entropy. To recognize such evidence requires not only science but imagination. Because to see the past in stone is to remember that the universe itself is the ultimate artist, sculpting civilizations into myth and myth into geology. The archaeology of Mars, then, is not only about what once lived there. It is about what we choose to see and what we are capable of understanding. Our technology will advance. Our machines will learn to recognize what we cannot yet comprehend. Artificial intelligence will study the surface of Mars, grain by grain, looking for patterns invisible to the human eye. The line between archaeology and prediction will blur. We will not only dig into Mars, we will train the future to see what we cannot. In that sense, this is not just planetary science. It is prophecy, because the archaeology of Mars is also the archaeology of us. Every rover, every probe, every human who will one day step onto that soil will be part of a much older journey, a return home. Each discovery will peel back another layer of our collective amnesia. Perhaps one day we will stand on the red plains and find a fossil that looks familiar, too familiar. And we will realize that the story of life is not a line, but a loop. Maybe Mars and Earth are not separate worlds at all, but two chapters in a single cosmic autobiography, a story of loss, migration, and rebirth written across the solar system. When we search Mars for its ruins, we are really searching for our own. We are the archaeologists of our origin, explorers of a forgotten ancestry buried beneath 1 billion years of silence. The future of this search will be extraordinary. Within the next few decades, humans will walk on Mars. They will pick up stones with their own hands, analyze them on site, and gaze across the same horizon that once inspired our myths. They will not be explorers of a foreign planet. They will be descendants returning to their ancestral ground, unearthing not just what Mars was, but what we once were. And as dust swirls around their helmets and the sun sets dimly through the thin sky, they may come to understand something profound, that the boundary between planets is not the boundary between worlds, and that archaeology, whether of the past or the future, is really a study of continuity. Reflective transition to the next chapter. In the end, every discovery on Mars brings us closer to the same revelation, that life is ancient, persistent, and endlessly creative. What we uncover there may not only rewrite the history of another planet, it may rewrite the story of life itself. Because when we dig into the red dust of Mars, we are, in truth, digging into the memory of the cosmos,